GameSci.com. GameSci.com. Welcome to GameSci.com. I am Professor Chris Ferguson. Enjoy the course.
Howdy, howdy, howdy. Welcome to the lesson on arrays. Arrays are where we store large amounts of data. An array is an ordered collection of items or elements. If you need 2 or 3 variables, you don't need an array. But if you need 200 or 300 variables, yes, you very much need an array. I like to say arrays are for storing mass quantities of variables. You can access the array as a collection, as a whole, or you can access the individual elements. Think about a 6-pack of soda pop. If you want the whole collection, you can buy all 6. But if you want to peel off a can and take it up to the counter and buy just one of the collection, you can. And arrays allow us that same ability to access the entire collection as a group or access one individual item. Let's create an array. This is a declaration of the array the money. In any video game that deals with money, you're going to have multiple players and they're going to have different bankrolls. So what we're going to do is for every player in the game, allocate this one array to keep track of how much money they have. When you see the square brackets, read that as an array. I'll read this line up here as double array the money. Read this as the array. Double array the money. And this here is called an initialization list. It'll initialize the positions in the array to these values. Beginners are most often confused that arrays start at index or subscript 0. The first number in this array, 2025, is at position or index 0. I know it seems strange to say the first item is at position 0, but that's exactly how arrays work. Now, where did the numbers come from? Well, this is called an initialization array. When you set it equal to something and in curly brace, you give it a list of items that you want to store in the array. First amongst this list of items is the number 20.25, and you can see it goes at position or index 0 of the array. The next item in this list, 19.0, goes in position 1 of the array. This is just like parameters. They line up one for one. The first number goes in position 0. The second number goes into position 1. The third item in the list goes at index or subscript 2. The number you see above the array, the 2, is what we call an index or a subscript. Sometimes I'll call it to the slot. This array is a collection of 5 doubles, and this 2 identifies which of the 5 numbers I'm accessing. The fourth item goes in position 3. The 82 is why an 82 appears in index or slot 3. And finally, the last item of a 5-item array goes in position 4. That may be the hardest part for beginners. Getting used to this first item is at position 0 of the array, and the last item of a 5-item array is in position 4 of the array. Get used to it. That's the way arrays work. Now that we've created this array and filled it with numbers, let's look at how we can use the numbers in the array. Let's say we want to access how much money the player at position 0 has. So I'll execute a line of code, player money equals the money index 0. Pull the value out of array index 0 and assign it to the variable player money. So array subscript 0 pulls out a 20.25 and transfers it to the variable player money. Player money is a separate variable outside the array. I pulled something out of the array and assigned it to that variable. And you can also put something into the array. Let's insert a value into array subscript 3. So let's take the contents of the variable player money, 20.25, and assign it to the money subscript 3. So the 20.25 that was stored in the variable player money gets transferred to array position 3. See that 3 right there? What number updated? Position 3 of the array. Let's access the array in a different manner here. Let's access the value stored in the money of index or subscript 4. So we're going to pull out the value 475 from subscript 4. We're going to add to that the hard-coded or constant value 5.50. Add those together, you get a 1025. Well, what are we going to do with this 1025? If you look closely on the left side of this equation, we're going to assign the 1025 to subscript 4. So subscript 4 was overridden and changed to 1024. And this is just like a video game. Player at position 4 just got or acquired $5.50 more. Let's add it to their total and store it back into the array that keeps track of how much money each player has. Not complicated. It's pretty simple once you understand the array as sort of a multi-part variable. It's a variable. Instead of storing one value, I can store multiple values in it. It's pretty easy to follow arrays. Let's do it again. Let's access the array at slot or index 1. Pull the value at position 1 out. That is a 19.0. So the 19.0 gets pulled out of the array. I subtract from that a 12.25. If you do the math, this comes out to be 675. What are we going to do with the 675? We're going to assign it back to index or position 1 of the array. So I pulled the current player's value out, subtracted an amount, and stored the result back into their total. And that's all an array is. There's nothing complicated about it. When you want to store 2 or 3 variables, you don't need an array. But if you're developing an online video game with hundreds of players and you need to keep track of how much money each of those hundreds of players has, an array is a nice way to do it. I'd rather declare one array than try to declare 100 individual variables. Let's look at declaring arrays and the different ways we can declare arrays. Turns out there's 3 different ways to declare an array. The first one you've already saw it on the previous slide. That's where you declare an array and give it an initialization list. Recall from the previous slide where we said equal curly brace, gave it a list of numbers, and close curly brace. Well, that kind of does everything. It declares the array, it sets the size of the array, and it fills it with values. But you don't have to do that every time. Imagine if you were building a large array, you're not going to want to sit there and type out all the values for the array. The second way you can declare an array is just declare the array. You don't have to give it a size. You don't have to give it values. We're just going to declare the array. Then the third way you can declare the array, you can give it a size by setting it equal to new and telling it what size you want to give the array, but you do not have to fill the array with values. We've already looked at the first way. Let's look at the second and third way to declare an array. I've got a hint for you. In Java and C#, arrays are objects. Let that sink in. In Java and C#, arrays are objects. Now that's not true for every language. C and C++, arrays are not objects. But in Java and C#, they are objects. What I'm going to do here is we're going to be declaring an object variable called int array hand. Remember, when you see these square brackets back to back, think array. I read this as int array hand. And what we're declaring here is an object reference variable called hand. Any object reference variable that doesn't have an object automatically gets assigned the value of null. And all this null means is I haven't assigned an object to this yet. What we're doing here is declare only without creating the array yet. We can always create an array later on. I want to make it clear here. Hand is an array. It is not an int. And more specifically, hand is an array object reference. It is not an int. Let's create the array here. See that new command? That says I want to allocate some new memory. So I'd read this as I want to build a new int array size 5. Allocate me enough memory to hold 5 integers. With this syntax, new int 5, the array will automatically be filled with zeros. That is the default values for a numeric array. When you create a numeric array without giving it initial values, it will fill the array with zeros. Broken this line up into 2 pieces to show you that the new int 5 creates the array. the array with 5 positions in it, 0 through 4. I then assign that array to the hand variable. The array that I declared up here, I attach my array object to the hand variable. That's what I mean by an object reference. The hand is a reference variable that lets you access this array. Now let's start using the array. You use the array by using the square bracket syntax. I want to go to the hand array, and at index or subscript 0, I want to assign a 14. So there is a 14 at subscript 0 of the array. Next line of code, I want to go to the hand array, and at subscript 1 or slot 1, however you like to say it, I want to assign a 6. So a 6 gets stored in position 1 of the array. Now I want to go to hand subscript or index 2 and store a 51 at that location. So a 51 gets assigned to subscript or position 2 of the array. Those are the only 3 values I assigned to it. Then 3 and 4 stay 0. There's no big deal. Nobody says you have to use every slot of the array. And in fact, because of difficulties increasing the size, we generally create our array a little bit bigger than we need. It's better to have extra slots into the array than to run out of room. This next line of code is to reinforce this idea that arrays are objects. In Java and C#, arrays are object. What we're going to do is use the hand object variable to access the length property. Also stored in this array is how many slots have been allocated. Now be careful here. Length means how many total positions are available in the array. Not how many we've used, but how many total we have allocated. You can see clearly up here, we allocated 5 slots, or 5 indexes in this array, and that's what hand.length returns. It says you allocated 5 spaces in the array. I will assign it to this variable len, short for length, and you can see the 5, the total number of slots allocated for this array, got stored in the len variable. In Java and C#, you never need to wonder how big an array is. An array can always be found out by asking it how many positions have been allocated. The length property, or the length variable, tells you how big the array is. Let's look at the third way to declare the array, where we declare and size the array at the same time. This line of code does 2 things. It declares and creates the array object, and it allocates 52 slots for that object. Look at this line of code. Int array dec equals new int 52. What are we doing? Well, number 1, we're declaring dec as an array variable. Dec, like a deck of cards, is not an int. Dec is an array as specified by these square brackets. Then I'm going to create an array object with 52 slots in it. I debated whether I should draw 51 lines here and draw the numbers 0 through 51 up here. In the end, I decided I'd have to scrunch them in so tight it wasn't worth it. Let's just say that there are 52 integer slots available in this array. With this syntax, it'd all be filled with zeros. But this line of code not only declares the array dec, it allocates the object with 52 slots. One more thing I want to talk about the dec before we leave. If we were to access the dec.length, what would we see? We'd see a 52. The length of this array was allocated at 52 slots. There are 52 zeros over here. I didn't have space to show you 52 zeros there, but they're there because we asked for 52. Starting to see the picture? Starting to get the idea of how arrays work? Let's look at arrays of objects. We've seen arrays of ints and arrays of doubles. What happens when you're storing an object in each slot of the array? Arrays of objects store a reference in each slot. The whole object doesn't get squeezed into the array slot, but a reference, a variable that points to the object, gets stored in each slot. Creating a string array players, let me highlight this, string array players, that's how I want you to read it. String array players equals new string array 5. We're going to declare the array players. Players is an array. It is not a string. Players is an array, not a string. We're going to declare players, And we're going to create an array with 5 slots capable of holding a string. That's what this looks like in computer memory. Players is a reference to our array object. It has 5 slots on it. And because we have not assigned strings to each slot, it will be filled with null. You remember what the value null means? Null indicates an object reference variable that doesn't have an object. Nothing on this line of code creates 5 string objects. It creates an array, but it doesn't create the strings. You may be wondering why my arrays all have the length of 5. I want to rest assured that you do not have to create your arrays with the length of 5. It just so happens 5 is a nice size to fit on this screen. You can have an array of strings of 50 or 500 or 1,000. If you're programming an online video game with hundreds of players, you want to keep track of those hundreds of players, create an array of strings to store their player names in it. Since we don't have any strings in our array, let's write a for loop to go through each slot of the array and assign a new string to each slot of the array. Declare int I equals 0. I'll set up a variable I here over on the right side with the value 0 in it. 0 is always the first slot of the array, so when we're going to loop through the array, we usually start at 0. 0 less than 5 is definitely a true statement. This array has 5 slots into it, and 0 is the first one, so this is absolutely a true statement. As a true statement, what's going to happen? We're going to go inside the loop and execute the code in the loop. And we'll ask the user for the player name. So we'll output to the screen, enter the player's name. And you can see that that output showed up here on the screen. What's going to happen now is then we're going to wait and ask for the user to input. Input.nextLine is Java code for reading a line of input from the keyboard. The player typed in Viper to indicate player 0 is going to be Viper. Viper got returned and assigned to player slot 0. Position 0 got Viper assigned to the array. We're using an index variable, or I, to keep track of which slot of the array. That's it. Let's loop and continually ask the player. How does a for loop work? When we hit the end of the for loop, it will spin back up here to the for statement. The first thing it'll do when it gets back to the for statement is execute the I++. The I++ will change the value of I to 1 and then test the condition again. 1 less than 5 is a true statement. As a true statement, we are going to enter the for loop again and ask the user to enter a player name. Spitting enter a player name out to the screen a second time, we're prompting the user to enter values for the array. This line of code will first execute input.nextLine. Input.nextLine will wait on keyboard input until the user types in and hits enter. So the user typed in elk and hit the enter key. As soon as they hit the enter key, the result of their typing gets assigned to player subscript I. Well, I contains the 1. So we're accessing slot 1 of the array and assigning elk to position 1 of the array. Are you seeing it? We can assign different values to the array using a subscript, and that subscript can be a variable. In fact, more often than not, it is a variable. We'll hit the end of the for loop, which says spin back up, and execute the for loop again. When we get back up here, we do the I++ first, and I goes to the value 2. After that, we'll check the condition. 2 less than 5 is a true statement. As a true statement, we will absolutely enter the loop again and ask for another name. Output to the console, enter a player name. You can see that and popped up right there on the console. We'll go to input.nextLine and execute that first. It'll ask the user to type in some letters. This time they enter bond. They type in the word bond and hit the enter key. As soon as they hit the enter key, what they typed in is assigned to player subscript I, which contains a 2. So at position 2 of the array, the string bond was assigned. What I want you to do is look at that picture carefully. Earlier I told you an array of objects stores a reference in each slot. We do not store the word bond in slot 2 of this array. We store the reference to a string object that contains bond in that slot of the array. An array of objects is an array of object references. Hit the end of the loop to spin back up again. First thing we do when we get back up is we do the I++. I has now become a 3. Since it's a 3, when we check the condition, 3 less than 5 is a true statement. As a true statement, we're going to enter the loop again. When we enter the loop, we ask the user once again to type something on the screen. Please enter a player name. And that shows up on the screen. We'll go to the next line of code. The next line of code will first execute input.nextLine. Go to the keyboard and wait for the user to type something. The user then typed in born. After they finish typing in born, they hit the enter key. When the enter key gets hit, a string object is created and assigned to player's subscript I, which is 3. So in position 3 of the array, the string object containing born, or the reference to the string object containing born, is assigned to position or slot 3 of the array. One more time. Let's spin back up on the for loop. First thing we do when we get back up there is the I++. I++ takes us to a 4 in the variable I. 4 less than 5 is still a true statement. As long as this statement is true, the for loop will execute. So come inside the for loop again. Output enter a player name. Request the user type something in. Go to the next line of code and wait for the user to type. Input.nextLine will wait for the user to type in letters. The user types in powers and hits the enter key. When the enter key is pressed, it will then return a string object, and that string object will be assigned to player's subscript I. I is 4, so powers gets assigned to position 4 of the array. Time to loop again, but something different is going to happen this time. I loop back up because whenever I hit the end of the for loop, I go back up and try and execute it again. This time I++ takes us to a 5. What's interesting about that 5? Well, when I check the condition again, 5 less than 5 is a false statement. When you create an array 5 slots, it's going to have index 0 through 4. There is no slot 5 of the array, so it's time for this loop to exit. 5 less than 5 is a false statement. Follow the arrow. Because this is false, I will hit the end of the loop and no longer ask for player names again. That's it. Now this is a pattern. Get used to this. Int I equals 0, I less than array.length I++. This loop will be repeated over and over. Whenever you want to go through every slot of the array, repeat this loop. The only thing you have to change is the name of the array. Parallel arrays. Let's go back to the example of a multiplayer game. We want to write a game where up to 5 players can battle each other at one time. If we're keeping track of 5 players, we obviously need to keep track of their name or their handle or their screen name, if you will. I need an array to keep track of the 5 players that are currently playing. We also have the element of money in this game. So each player is collecting money as they go. Maybe they can buy new weapons with it. Maybe they lose money when something bad happens, pay ransoms, whatever it is. We need to keep track of names and money. We're going to do that by utilizing something called parallel arrays. 2 or more arrays where information in an index or slot corresponds to the same index in another array. Slot 1 in the players array, which contains elk, aligns to slot 1 in the money array, which contains 19. Player 1 has the name of elk, and they currently have the amount 19 in their pocket. The money value 19 in their pocket. That's what I mean by parallel arrays. Slot 1 of the array players, elk, corresponds to slot 1 of money, 19. So player elk has $19 in their pocket. Go back to the syntax where we both declare the array and assign it initial values. This string array players, let's follow this along. String array players equals curly brace and then a list of values that I want to store in the array. And you can see very clearly the first item listed goes into slot 0, Viper. The second item goes into slot 1, Elk. The third item goes into slot 2, Bond, and so on down the line. We are doing three things on this line of code. We're declaring the array players. We are allocating 5 slots in the array because there are 5 items in this list. And then we're filling each slot with a value: Viper, Elk, Bond, Born, and Powers. We'll set up our parallel array. This array is parallel to the first one. Everything in slot 0 of the players array corresponds to slot 0 of the money array. Whatever's in slot 1 of the player array corresponds to slot 1 of the money array. So I drew it exactly below, and this second line of code, double array money equals curly brace and a list of values. These values correspond one for one with the array above it. That's what I mean by parallel arrays. You can see it down here below. Slot 3 of the players array contains Born. Slot 3 of the money array contains 82. That means player Born has a bankroll of $82. Now a simple number will be able to refer to both values, the name and the amount. We'll go out to the screen and ask them to enter a player number, 0 through 4. Tell me which player in the player array do you want to access. At the same time, it will tell us how much money they have. I go to the screen and ask them to enter a number between 0 and 4. The input.nextInt is going to wait for the user to type in a number at the keyboard. You can see over here on the output that the player typed in a 1. I want to access slot 1 of the array. I stored it in a variable called slot, and I want to access the information in position or index 1 of both arrays. I boxed in position 1. Position 1 for the player array says that player is named Elk. But that player has this amount of money. So I go to slot 1 of the money array and I find the 19, and that's what we mean by parallel arrays. Access the players array to get the name for this output. Access the money array for the corresponding amount that that player has. Let's start over. I would have liked to put this in a loop, but there's no room to put it in a loop. So we're going to just ask the player again, enter a number, try a new index. Go out to the screen with another input, enter player numbers 0 through 4. I'll go back out to the keyboard and get an integer off the input. So let's see, the player entered a 4 this time when it came to the keyboard. They entered a 4 and hit enter. So the value 4 was stored in the variable slot. I've boxed in what the information we're going to access. We go to the players array first and find out that in position 4 of the parallel arrays, the player has a name of Powers. We then go to the other side and say has this amount, and we access the money array at the same position 4. The money array in position 4 says Powers has $4.75 in their pocket. Do you see what I mean by a parallel array? The name is stored in one array, players, and the amount of money that player has is stored in the second array, money. And index 4 of players matches or corresponds to index 4 of money. Trying it again, ask the user to enter a player number 0 through 4. This time, when it went to the keyboard and said pick up an integer off the keyboard, the player entered the value 0. The 0 was then returned after the enter key was pressed and assigned to the variable slot, and we have a 0 in variable slot. Well, I boxed in position 0 of the parallel arrays. I'll go to the player array first, and at position 0 it says we have a Viper in position 0. I will then look at the amount that the player Viper has by going to the parallel or second array money, and at position 0 of the money array it looks like Viper has $20. $5.25. That's what I mean by parallel arrays. The index works for both. Let's try it one more time. This time, maybe screw up, make a mistake. Go back to the screen and ask the user to enter a player number 0 through 4. This time, for whatever reason, when it went to the keyboard and waited for the next integer to be entered, the player typed in a 5. Ooh, that's not good. If you see this box up there, we've got a big problem here. There is no position 5 of this array. If you look closely here, 4 is the last position. So the player is asking to access a slot that doesn't exist. Yeesh. What happens here? I drew a box of where it's trying to access position 5 of the array, but there is no position 5. So I wrote out the words error, error, error. You're likely to get a much more nasty error message, something like array index out of bounds, that tells you there is no position 5 in player slot. It just doesn't exist. If you have a 5-element array, there's only positions 0 through 4. This is something you want to avoid at all costs. Do not, I repeat, do not try to access an array slot that doesn't exist. Get an error every time. That's it for parallel arrays. That's when you set up 2 or more arrays where the index or slot number corresponds in the other arrays. Time to look at an algorithm. Linear search. Linear search is something you do on arrays. I want to search an array to find an item, and we're going to do it in a linear manner, which means start at the beginning and go down the entire array. Linear search is a brute force algorithm that loops through the entire array looking for a value and returning its position in the array. Start at position 0 and just go down the list, and when we find it, we'll return the subscript or index where that item is located at. Let's call the linear search algorithm the linear search method. We'll pass it a parameter. We'll pass it an array. You can see the array at the bottom of the screen. We'll pass it to the parameter data, which means data and array will point to the same thing. And then we'll pass it a key. Now look at the variable key over here. Key contains a 50, so we're really passing the value 50 to the variable target. When we get inside routine, the variable data, the array, look at this, this says int array data, so the parameter data will be pointing to the same thing that array is pointing to. And target will be a local variable, so I popped up a new variable here, and target will be assigned the argument 50 because that came from the variable key. Local variables are created on demand, so the local variable target was just created. The local variable data was just created. We'll jump into a for loop here, and as we usually do with for loops and arrays, we'll start at index or slot 0. The reason we call this variable I is it's short for index. Position 0 says start at the beginning of the array. 0 less than 5 is very much a true statement. We're nowhere near the end of the array. As a true statement, we'll go inside the for loop and execute this if statement. We'll ask if target, which is 50, is equal to data slot I, or position 0 of the array. And that 50 in the variable target does not match the 20 that is in position 0 of the array. Now here's where we have to be careful. Normally I put curly braces around my for loop. I almost always put curly braces around my for loop, so it clearly shows the beginning and the end. But I was running out of room. I wanted to show this nice and big, and I was running out of room for curly braces. And I just need to get you used to the idea of when there's one and only one statement after an if statement, for instance, return I don't have to put curly braces around it. And there is one and only one statement inside this for loop. It's this if statement right here. When I finish this if statement, it's going to loop back up on the for loop. Curly brace or no, the for loop is still going to loop. When I get back up here in the for loop, I++ will set I equal to 1. 1 less than 5 is a true statement, so it's going to go inside the loop and execute the one and only one statement, the if statement. If target, which is 50, is equal to data sub I, which is 30, because I contains a 1, 50 matching 30 is a false statement. As a false statement, it will skip this if and loop back up on the for loop. When it loops back up on the for loop, I++ will say slot 2 or index to the array. That means we're going to be looking at this next. 2 less than 5 is very much a true statement. As a true statement, I'm going to go inside the for loop and attempt to execute this if again. Ooh, interesting. Target, which contains 50, is that equal to data subscript I? Well, I is 2, so we're looking at this value right here. Is 50 equal to 50? Why, that is a very much true statement. As a true statement, it's got to go inside the if statement and execute the code inside the if portion of the statement. And when it executes the code inside the if portion, it will return I. Well, what is I? I contains the value 2, so when it says return I, it's going to send a 2 back to that equal sign. Called linear search with an input of 50, and the output of linear search is going to be a 2. I send it back and execute the slot equals, and the 2 that was returned gets assigned to the variable slot. And just to make sure I boxed it in, I said search for 50, and it returns a 2 to tell me that 50 was at position 2. That's what a linear search algorithm does. You send it an input, find this in this larger array, and it tells you where in the array it's located. Let's try it again, but this time let's search for something that is not in the array. Let's search for a key of 25, and a quick scan of that array tells you 25 is not there. What happens when you search for something, when you linear search for something that is not in the array? Pass the parameters. Array gets assigned to the variable data. Key gets assigned to the parameter target. Target will contain a 25 because that's what was in key. And data will point to the same array here. Search array for the target 50. Same loop. Get used to this loop. This is sort of the standard loop for searching an array or going through every slot of the array. Start at 0, go strictly less than the length of the array, and do an I++ at the end to make sure that you cover them one by one. Looking at I less than data.length, 0 less than 5 is a true statement. As a true statement, we're going to go inside and execute the if. The if says if my target 25 is equal to data subscript I, which is 20, I contains a 0. Does 25 match 20? Well, that is a false statement. As a false statement, we will loop back up and execute the loop again. Every time this if statement is false, we will just turn right back around and execute the for loop again. I++ says search position 1 of the array. 1 less than 5 is a true statement. As a true statement, it will execute the body of the loop and ask is target 25 equal to data subscript I, which is now 30. That is still a false statement, so it's going to loop back up and execute the for loop again. I++ goes to 2. 2 less than 5 is a true statement. It's time to go inside the loop and execute the if. Target, which is 25, does that match data subscript I, which is 50? That is a false statement. As a false statement, we're going to loop back up on the for loop again. We're searching for something that doesn't exist. I have a feeling we're not going to find it. I++ goes to 3. 3 less than 5 is a true statement. As a true statement, it'll go to the if again. The if is 25 equal to data subscript I. Subscript I is 10. 25 does not match 10. That's a false statement. Loop back up. I++ sends I to 4. 4 less than 5 is a true statement. Let's check the last item in the array. Does target match data subscript I? Does 25 equal 40? That is a false statement, and we're going to loop back up. Looping back up, I++ goes to 5. That's an interesting number. Check the condition again. I less than data.length is 5 less than 5. This is very much a false statement. When this statement goes to false, we exit the for loop. When we exit the for loop, we execute the first code after the for loop. And this right here is the first code after the for loop. The return -1 is a flag. The -1 is a flag that we did not find the data. We searched down the entire length of the array, never found 25. The -1 is the flag that we return to the equal sign to tell it it wasn't found. When I execute the slot equals there, you can see the -1 showed up in slot. And a simple check of slot as a negative number will tell you the linear search failed. The key value 25 was not found in the array. There you have it. That's the linear search algorithm. Return the subscript of the slot or index of the data if you find it. Return -1 if it's not found in the array. Time to look at the bubble sort algorithm. The bubble sort algorithm is designed to take an array that is out of order and put it into order. Let's say you're programming a video game and you're tracking everybody's high score, and you don't want to know who has the greatest or the largest score. Well, you can put that in an array, sort it, and who's ever at the end has the high score. You'll also find the low score at the beginning of the array. Bubble sort. Take data in an array that is out of order and put it into order. I wrote the code for bubble sort here. This time I made sure I put in the curly braces because it's a little more complicated code. We're going to set up a variable called outer and set it equal to array length -1. And what that's going to do is kind of give us a target. All right? The goal of bubble sort is to bubble or move the largest number we can find to this outer position. So I'm going to go through this data and move the largest piece of data I can find to this outer position. Outer greater than 1, well, 4 is greater than 1 is a true statement. As a true statement, we will execute this loop. We'll jump into the inner loop, set inner equal to 0. And that means we want to start at the beginning of the array. 0 less than 4 is a true statement. As a true statement, we're going to go inside the for loop, follow the arrows on this one. And we're going to ask if the array of inner is greater than the array of inner plus 1. The way this algorithm works is it slides down the array and compares two adjacent numbers. And if those two numbers are out of order, it swaps them. If they're not out of order, it leaves them alone. 20 greater than 30 is a false statement. 20 and 30 are not out of order. So what it decides to do is nothing. As a false statement, it is going to take this path and skip the swap. Those two numbers are in order. Leave them alone. And that's good. Bubble sort likes it when it leaves the number alone. After the if statement, we'll hit the end of this inner loop. Notice how I put a comment in there to say this is the inner loop. That's the inner loop right there, controlled by the variable inner. We hit the end of the inner loop. That means we got to spin back up under this inner for loop. When we spin back up on the inner for loop, we'll execute an inner plus plus. We're going down the length of the array like we typically do with an array. Inner plus plus goes to 1. That's pointing to there. 1 less than 4 is still a true statement. Into the for loop we go, and we ask if array sub inner is greater than array inner plus 1. Is 30 greater than 50? And the answer to that, once again, is false. These two numbers are not out of order, so leave them alone. We'll skip the if statement, jump to the end of the if statement. When we hit the end of the if statement, we'll go to the end of the inner loop here. When we hit the end of the inner loop, we'll loop back up on our inner for loop. When we get to our inner for loop, we'll add 1 to inner. We'll slide farther down the array to position 2. 2 less than 4 is still a true statement. As a true statement, we're going inside this for loop again. Now it gets interesting. Array sub inner, which is 50, is that greater than array sub inner plus 1, which is 10? That is a true statement. 50 and 10 are out of order. Somebody needs to fix it. And that's what that if statement will do. Since this was a true statement, it's going inside the loop. It sets up a temporary variable in temp here, and it takes array sub inner, that 50, and moves it to the temporary variable. Once 50 has safely moved to temporary, it's going to move the 10 at array sub inner plus 1. That's the 10 right there, inner plus 1. It's going to move it over to array sub inner. It's going to wipe out the 50 that was here before. But don't worry about that 50. It's safely in temp. We'll take it from temp and move it to inner plus 1. What we just executed there was called a swap. When you want to swap two numbers in the array, you want two numbers to change places in the array, it takes a third variable and 3 assignments to do it. So we shifted the 50 out, we moved the 10 over, and then the 50 replaced or swapped with 10. At the end of the if statement, what are we going to do? We're going to advance to the end of the inner loop. When we reach the end of the inner loop, what are we going to do? Why, we're going to loop back up to this for statement again. Inner plus plus takes us to position 3 of the array. Again, we're sliding down this array, swapping numbers that are out of order. 3 less than 4 is still a true statement. As a true statement, we're going to go inside this loop and execute the if statement again. Array sub inner contains a 50. Is that greater than array sub inner plus 1? All we're doing is comparing adjacent numbers, and if they're out of order, we want this to be true. And that's the case. 50 and 40 are out of order, so the statement is true. We're going inside the if statement to do our swap. And these 3 statements represent our swap. 50 and 40 are out of order. Swap them. The 50 in array sub inner gets sent to the temporary variable. The 40 at inner plus 1 moves over to replace the 50 right there. And then the 50 comes back down out of the temporary variable into the array, and 40 and 50 just swapped or changed places. When we're done with the if statement, we'll go to the end of the for loop, the inner for loop. When we're at the end of the inner for loop, we pop back up and do it again, because that's what for loops do. Inner plus plus will take us to 4. That's interesting. Now when we look at inner less than outer, that is a false statement. We reach the end of the line. After one pass through this array, 50, our largest number, is in our outer or target position. We don't need to go any farther. It's time to exit this for loop. When we exit the inner for loop, we'll hit the end of the outer for loop. When we hit the end of the outer for loop, we pop back up here, and we're going to do outer minus minus. Now, see how I kept that outer pointer there? Outer stays there as long as we're going down the array. Now it's time to change that. The outer minus minus will tend to 3, and what we're going to do is repeat the same thing. We are going to move the largest number we can find to this position, position 3. 3 greater than 1 is a true statement, so we'll enter the outer loop and execute the inner loop. Inner loop starts over from the beginning, and we'll go down the line, moving the largest number it can find to position outer. 0 less than 3 is now a true statement, so I'll execute the if. 20 greater than 30 is a false statement, so I'll skip the swap. When I hit the end of the inner loop, I spin back up. When I spin back up, inner plus plus says go to position 1. Something's going to happen here. 1 less than 3 is a true statement. As a true statement, it will enter the for loop and execute the if. Array sub inner 30 greater than array sub inner plus 1, that is a true statement. 30 and 10 are out of position, so it's time to swap 30 and 10. The temporary variable gets array sub inner. Array sub inner plus 1 moves over to array sub inner, so the 10 slides over and wipes out the 30. But don't feel bad about the 30. It safely moves back from the temp variable to my array, and 10 and 30 just swap positions in the array. Are you starting to see the sort going on here? If you look closely at those last three numbers, they look like they're in order. We'll hit the end of the if statement, which will reach at the end of the inner for loop. The end of the inner for loop takes us back up to top. Inner plus plus takes us to 2, and now inner will be pointing at slot 2 or index 2 of the array. Array sub inner greater than array sub inner minus plus 1. Is 30 greater than 40? That is a false statement. We're going to compare adjacent numbers, and every time they're out of order, swap them. Well, they're not out of order. 30 and 40 are in perfect order. So skip the swap. Hit the end of the inner loop. At the end of the inner loop, we'll come back up and do an inner plus plus. When inner plus plus goes to 3, notice how we've reached the end. Notice how inner and outer are pointing to the same position. 3 less than 3 is a false statement. We've now gone through this inner loop twice, and look what we have. We have the two largest numbers at the end of the array. We'll hit the end of the outer for loop and say spin back up on the outer for loop. Outer minus minus is going to change our target. Outer minus minus is going to set outer equal to 2 and say scan the data and move the largest number you can find to position 2. 2 greater than 1 is a true statement, so we're going to go inside the loop and execute the inner loop. Inner once again starts over at 0. Every time through the inner loop it starts over at 0. Start at position 0 and go to outer, swapping numbers when you see they're out of order. 0 less than 2 is a true statement, so we'll go to the if statement. When we get to the if statement, array sub inner 20, is that greater than array sub inner plus 1, which is 10? Very much a true statement. As a true statement, it's going to go inside the if statement and execute the swap. The 20 at position 0 gets moved to temp. The 10 moves over in the array and wipes out the 20 in the array. But don't feel bad about the 20. It's safely in the temporary variable and moves back down to array inner plus 1. 10 and 20 just swapped. We reach the end of the swap, which means the next line of code that executes is the end of the inner loop. The end of the inner loop takes us back up to the top of the inner loop. Inner plus plus goes to 1. 1 less than 2 is a true statement, so we're going inside and checking that if statement once again. Array sub inner 20, is that greater than array sub inner plus 1, which is 30? Absolutely not. Those two numbers are not out of order. Leave them alone. Skip the if. When you reach the end of the if, go to the end of the inner for loop. When you reach the end of the inner loop for loop, go back to the top of the inner for loop. Do an inner plus plus, which takes us to 2. Inner less than outer. 2 less than 2 is clearly a false statement. As a false statement, we will exit the for loop. When we exit the inner for loop, we'll reach the outer for loop. When we reach the outer for loop, we'll spin back up and execute outer minus minus. Outer minus minus takes us to 1. 1 greater than 1 is a false statement. When this statement goes to false, what happens? We need to exit the outer loop. And when we exit the outer loop, our sort is done. Did you see it? This data started in mixed up order. It was out of order. By spinning through these two loops, we placed it in order. That's what we call a bubble sort. A bubble sort bubbles the biggest number it can find to the end of the array. Then it repeats the same process, moving the biggest number it can find to a position 1 less than the end of the array. And it repeats it again to the next position, and so on down the line. When you get down to position 1, your data is going to be in order. One more algorithm, the binary search algorithm. We looked at linear search, bubble sort, and now the third algorithm is going to be binary search. Now, one of the reasons we do a bubble sort is to get our data in order so we can do a binary search. Binary search requires sorted data. Linear search is slow. A much faster algorithm is binary search, but it requires a sorted array. Don't even attempt a binary search unless your data is in order. Often it requires doing a bubble search before you can execute a binary search. This time I want to focus on the algorithm itself, not on the code. So all I'm going to show you is a call to binary search. I'm not going to go through the code line by line. Binary search is a divide and conquer algorithm. Binary search works by repeatedly chopping the problem in half. We're going to start in the middle of the array and decide which side to search by what's in the middle of the array. This is what we call divide and conquer. It's a little easier when you see it. Let's execute a binary search on this array right there. There's my array of sorted data. Again, don't even try this unless your data is in order. Let's execute a binary search and look for the value 50. It's going to start in the middle of the array and decide from there what to do. The key of 50 is what we're searching for, and we're going to return the slot number of where we find the data. Here's how binary search works. It says search between index 0, that's the blue arrow here, and index 6, that's the green arrow here. Calculate the middle of the array, which is 3, and decide by looking at this middle item which end of the array to search. Well, if I calculate the middle of my array and compare 50, what I'm looking through, to 45, 50 less than 45 is very much a false statement. When my target is not less than the middle item, 50 must be to the right of the array. Look closely here. I'm looking for 50. It must be, because this is sorted data, on this side of the array. And that's where binary search gets its speed improvement. Rather than searching through all the data until it finds 50, it starts on the middle and chops the problem in half. So that one comparison says, I better look at this data now to see if I can locate a 50. Well, how does it do it? Well, if chopping it in half was good the first time, let's do it again. Let's adjust our search parameters to search between index 4 and index 6. The middle between 4 and 6, 4 plus 6 divided by 2, is index 5. So the blue arrow is the start of our search range, the green arrow is the end of our search range, and the red arrow is our middle item. 50, our key or our target, is less than 65. That is a true statement. When what we're looking for is less than the middle item, then 50 must be to the left. All we're doing is process of elimination. What we're looking for is less than 65, so it has to be on this side of 65. Which means we'll adjust our search parameters to search between 4 and 4. We know it's greater than this, so it must be on that side of 45. We know it's less than that, so it must be on that side of 65. At this point, we're search between index 4 and index 4. Calculate the middle by saying 4 plus 4 divided by 2, which is 4. We're going to search this position of the array. And what happens? 50 equals 50 is a true statement. By constantly looking at the middle item and going left or right depending on its value, we came to index 4 and we found 50. Well, who's going to get that index 4? We'll send the index 4, 50 was found at position 4, back to the calling routine. The calling routine says take my reply and assign it to the variable slot. Take the 4 where 50 was found and assign it to the variable slot, and you can see slot has picked up the value 4. That's what binary search does. It chops the data in half until it locates the target, and then it returns the subscript of the item that you're looking for. Let's try it again a little differently. Let's use a variable instead of a hard-coded value. We'll set a variable key equal to 30, and 30 will be the parameter that we pass to binary search. Launch our binary search with the key of 30. Look for 30 in the sorted array. Search between the beginning of the array, slot 0, and the end of the array, slot 6. Calculate the middle as 0 plus 6 divided by 2. Begin our search for 30 in the middle of this array. 30 less than 45 is a true. When what we're looking for is less than the middle item, we need to go left. I think anybody can see if there's sorted data, simple logic tells you if you're less than that middle item, you better search to the left of the item. Now, how do we search to the left of the item? We adjust our search parameters. We take the end of the array, which was way over here, and say, okay, make this the end of our search range. Search index between 0, the blue arrow, and 2, the green arrow. Calculate the middle as 0 plus 2 divided by 2, or 1. Search again for 30 using the middle item at slot 1 and see what happens. 30 less than 25, when we look at the middle item of our remaining range, is a false statement. As a false statement, 30 must be to the right of 25. When 30 is to the right of 25, we'll adjust our search parameters to search between index 2 and index 2. Calculating the middle as 2 plus 2 divided by 2 says we are going to search starting at 2, ending at 2, and the middle item is going to be 2. I have a feeling things are going to be different this time. Our target, our key was 30. We compare what we're looking for, 30, to the middle item of our search range, and it's true. They match. If they match, we're going to return found at index 2. Again, we don't return 30. We return the position where 30 is at, and that's the 2. Where's the 2 going to go? It's going to go back to whoever called binary search. This is the line of code that called binary search, so I'm going to execute that equal sign right there. When I say slot equals, the 2 that we found our 30 at gets assigned to the variable slot, and our binary search is complete. 30 was found at index 2 of the array. Let's do something different. Let's use a variable to search, but this time let's search for something that isn't in the array. So set key equal to 80. So our target or our search value is 80. Execute our binary search and look for 80 starting in the middle and comparing 80 to 45. Our search range is from the beginning of the array, that's the blue arrow, to the end of the array, that's the green arrow. Search between those two slots of the array by calculating the middle. 0 plus 6 divided by 2 is 3. Calculating the middle of our search range, look at index 3. 80 less than 45 is a false statement, which means 80 must be to the right. It has to be the right. This is a sorted array. If you're bigger than that number, I want to search these 3 values. I'll adjust the search range to say search between index 4 and index 6. Calculate the middle. 4 plus 6 divided by 2 is 5. And my search will look at position 5 to see if it can find 80. 80 less than 65 is a false statement. What I'm looking for is less than the middle item, so I must search to the right. Search between index 6 and index 6. Go to the end of the array. Calculate 6 plus 6 divided by 2 is 6, and I'm going to look in that position for 80. 80 less than 70 is a false statement. 80 must be to the right. The only problem is there's no more data to the right. When there's no more data to the right, yikes! The blue arrow crossed the green arrow. When this blue arrow, which was on this side, goes past the green arrow, That means we've run out of numbers. We chopped the data in half until there was no more data to look at. When that happens, we've got to return a not found. And I think the best value to return for not found is -1. If you did a binary search on the data, could not find it, return a -1. Again, there is no array slot -1. A -1 is a flag to tell you the data wasn't found. There's binary search. I hope you enjoyed it. We're getting into the process of learning algorithms. Algorithms are a plan to solve a problem. We want to search data. We want to sort data. Remember, binary search requires having the data in sorted order. The advantage of binary search is it eliminates half the remaining items with each comparison. That's why it's much faster than linear search, which only eliminates one item. A linear search says look at one number and search all the rest of them. A binary search says look at one number, the middle number, and only search the remaining half, the half that the data you're looking for has to be on. It's a little hard to tell with a small amount of data, but as the arrays get bigger and bigger, binary search is much faster than linear search. Well, I hope you enjoyed that lesson. Once again, I'm Professor Chris Ferguson. Please visit us at gamesci.com to see more interesting lessons.